You save a photo on your phone, and within seconds it appears on your laptop, your tablet, and if you asked, on a friend's screen across the world. No USB cable, no email, just a tap and quiet confidence that the file will be everywhere you need it. That confidence is backed by a complex global system most people never think about. Let us get this out of the way immediately. The cloud is a building. Several buildings, actually. Each one is filled floor to ceiling with servers. Thousands of computers running continuously, cooled by industrial air systems, backed by diesel generators, and connected to each other by networks running faster than anything you have at home. Your file is not floating. It is sitting on a spinning or solid-state drive somewhere on Earth. When you upload a file, the client application on your device does not send it as one blob. It splits the file into chunks, often a few megabytes each. Each chunk is compressed if the format allows and assigned a hash, a unique fingerprint. If two users upload the same file independently, some systems detect matching hashes and skip a second upload entirely. This is called deduplication. Traditional file systems use folders and paths. Cloud storage often uses a simpler model called object storage. Each piece of data is an object with a unique key and attached metadata, size, owner, creation date, content type. There are no folders in the traditional sense, just flat namespaces. This flatness makes object storage scale to billions of objects without the hierarchy becoming a bottleneck. The moment your chunk lands on a cloud server, it does not stay there alone. The system immediately replicates it, typically to at least 3 drives across at least 2 physical locations. Some providers replicate across 3 geographic regions. If a drive fails, a server catches fire, or a natural disaster destroys a data center, your file survives because copies exist elsewhere, already up to date. With billions of objects scattered across thousands of drives in multiple regions, the system needs a map. A distributed metadata index stores the location of every object, which data center, which rack, which drive, which offset on that drive. When you request your file, the index is consulted first, the location is returned in milliseconds, and the actual object is fetched directly. Retrieving a file from a data center on another continent would be slow. Cloud providers solve this with content delivery networks. Edge servers positioned in cities worldwide cache frequently accessed data close to users. When you download a shared file or stream a video from cloud storage, you are likely hitting an edge node within 50 milliseconds of you, not the origin data center. Sync is not magic. A daemon process runs quietly on your device, watching for file changes. When it detects a change, it uploads the delta, the changed portion, rather than the entire file. The server reconciles versions using a conflict resolution policy, last write wins, merge, or flag for manual review. Sync engines are some of the most subtle and carefully engineered software in daily use. Here is something most cloud users never picture. Your single file is not stored whole on one drive. Erasure coding can split a file into fragments, adding redundancy fragments, so any subset of fragments can reconstruct the original. A 100 megabyte file might be split into 14 shards, stored on 14 different drives or servers, with any 10 sufficient to rebuild it. One drive can die, and your file is untouched. In 2021, a major cloud provider's regional outage took down thousands of services for hours. The providers that recovered fastest had data replicated across multiple regions and automatic DNS failover pointing users to surviving regions. Those without cross-region replication simply waited. Redundancy is not a feature. It is the difference between availability and apology. From save to safe, the client chunks and hashes the file, uploads over encrypted connection, object storage assigns a key and metadata. The replication engine copies to multiple regions, CDN edges cache it for fast retrieval, and the sync engine propagates changes to all your devices. Every piece working together means your file survives almost anything. If your relationship with the save button just got more complicated, welcome to the club. Subscribe for weekly system breakdowns in plain English. Next time, we trace how streaming video travels from a server to your screen in real time, at full quality, without you waiting for the whole file to download. This is System Sketch.